Let us run through complex numbers and blend them with matrices. So, getting started already, let us look at complex numbers. So, we're going to discuss the rectangular form and the polar form, and then we'll jump to the Moivre theorem. Yeah. So now, getting started with the rectangular form. The rectangular form of a complex number. So this is simply the normal way of writing a complex number. So a complex number, it is written in the form x plus iy. So x plus iy, like that, where x is the real part and then y is the imaginary part. So the I simply meaning imaginary. And then some textbooks, they would use this notation. So simply meaning A is the real part and then B, it is the imaginary part. Yeah, so for most of this discussion we'll be using this notation. And then now when we talk about the polar form, it is whereby we now introduce trigonometric ratios. So the real part, it is written by cos theta. We write it as r cos theta plus the imaginary part, we write it as it will start with I as well, so I r sin theta, and then you can see that r is common on both sides. So when we factor it out, the polar form looks like this, like that. So we have I sin theta. So you have to know how to convert from rectangular to polar form. Yeah, so that is what we're quickly going to do. And then also vice versa, from polar form going to rectangular form. Yeah, so on the polar form, you would want to take note that r is simply the modulus, and then theta, it is the argument, which is the angle. Yeah, so there is actually a document, on an introductory document to complex numbers, so you should check it out. So now we're going straight now to the conversions. Yeah, and then we'll get to talk about graphing. So this is an example saying express each of these numbers in two polar form. So this is rectangular. Rectangular simply meaning that we don't have trig ratios. When trig ratios are involved, we call it the polar form. So now, so this part which doesn't have the imaginary part, we call this x, and then this part with an imaginary part, it is y. So this is x without imaginary, and then meaning y, it is 0. Yeah, so here where we don't have x, this is the real part x, where we have an imaginary, that is y. Yeah, and then here you can see we only have the imaginary, meaning that the real part which is not having I, it is 0, so x is 0. So you need to know how to graph each of these. So the very simple way of graphing it is simply to know that here, like when x is positive, the line goes to the right, and then when y is positive, like here, the line in the y-axis, it goes up. Yeah, and then like here now, x is negative, it will go like this to the left, but y is also negative, meaning it will go down. So always know upwards and to the right it's positive, and then downwards and to the left this is negative. Yeah, so now we're now going to talk about converting. So we've said the rectangular form, it is given by r cos theta plus I sin theta. So we need to know how to calculate r, and we also need to know how to calculate theta, which is the argument. So r, it is given by x squared plus y squared, the root of these, and then the angle theta, it is given by tan inverse of y over x like that. So now we are now going to start with the first one already. So how do we convert this? So firstly we should find r. Yeah, so let's do this quickly. So r, it is the root of x squared plus y squared. So now what is x? So the real part here, it is 6 and it is having a root 3. So we square this, plus y, it is 6 and we square it. So the imaginary part, we don't include it there. Yeah, so and then here you quickly do the math and then you find the final answer. So 6 times 6, it is 36, and then the root cancels with the power, so you just remain with a 3. So plus here we have 36. So this simply means 36 times 3. When we multiply, we're going to get 108. So plus 36. Yeah. So and then 108 plus 36, it is 144. And we know the square root of 144, it's 12. So this is r. So we have established that r is 12. So meaning we know what we're going to put here. And then now what about this angle theta? So we're going to calculate the argument. So we say tan theta is equal to y over x. So one thing I mentioned in the document is that you always have to know that for these values, like if we have tan theta, if we have tan, what do we start with? Let's say tan 30. You always have to know that it is 1 over root 3. If you have tan 45, you always have to know that it's equal to 1. And if you have tan 60, you always have to know that it's equal to root 3. So meaning even here, like when we divide, if you just see that we're ending up with a root 3, just know that it's 60 degrees. If we're ending up with 1 over root 3, that's 30 degrees. Yeah, so this is a tip which I can give you. So now here to calculate y is, so always remember y, it is the imaginary part. So y is 6, x is 6 root 3, and then we can cancel 6 and 6 there. We're going to end up with 1 over root 3. So immediately you see 1 over root 3, you just know that okay, here I have 30 degrees. Yeah, so 1 over root 3, that's 30 degrees. So meaning our angle, it is 30 degrees. So but you have to check the quadrant so that you know what to put exactly here. Yeah, so if we plot this, x is positive and y, so x is positive and also y is positive. So meaning this angle 30, it is in the first quadrant. Yeah, so the full x or y plane is this. Yeah, so now here it simply means it's in the first quadrant. So if it happened that maybe let's say if it happened that x is negative and then y is positive, meaning we still have to read from the positive x-axis, meaning we'll start from here going all the way up to there, which would be like a 180. Yeah, so but since it's in the first quadrant, we just take it as it is, 30 degrees. Yeah, so we're going to say the angle there, it is 30. So we found our angle theta. So remember r, we found it was 12, and then theta, it is 30 degrees. I sine theta, it's 30 degrees. So and then you should also be very familiar that 30 degrees, it is pi over 6. Yeah, so always know 30 degrees is pi over 6. So here if we want, we can put pi over 6. Yeah, so and then we can do what now? Nothing. Yeah, so we found our answer. So I almost went now to like evaluate this. So like in the next questions, we're now going to talk about like changing this back to that. Yeah, so we can actually even do it like right now. So it simply means we evaluate this. What is cos 30? So remember cos, okay, so this is like more of revision. So if we want to find cos 30, it simply means we count the number of items above 30. So 1, 2, 3, meaning cos 30, it is root 3 over 2 there, and then plus sin 30, the number of items below 30, we only have 0. So we only have one item which is below 30, meaning sin 30, you know, it's 1 over 2. Yeah, and then this, remember there's a 12 outside, meaning here there's a 12, even here there's a 12. When we cancel 2 into 12, we're going to end up with a 6. And then here, this is I. 2 into 12 again, there'll be 6. So like it will take us back to there. You've seen how, so these are just like they are just things which will help us to go to the Moivre theorem. So maybe for now, let's just focus on converting to polar. Yeah, we'll eventually get there. So this is the polar form. So I was just trying to quickly show you that we can change it back to where we came from. And then now let's do the other one. So firstly I'll go to this one, -3 4i. So we always start with calculating r. It will be r is -3 squared plus 4 squared, it's a negative. So here -3 and -3, this is 9, and then this is 4 times 4, 16. So 9 plus 16, we're ending up with a 25. and then the square root of 25 we know is 5. So the resultant, the absolute value is 5. And then let's find the argument. So we say tan theta is equal to y over x. So always remember y is the part which is having an imaginary part. Yeah. And then the one not having an imaginary part is x. So y, it is negative 4 over x is negative 3. So this is 4 over 3. So and then now here this is a little bit problematic because we don't have a special angle for this. Like you can know that this is so like remember if we are the 1 over root 3, we know it is 30. If we have a root 3, this is 60. If you just have a 1, this is 45 degrees. Yeah, so but this one it would require a calculator, and then in mathematical methods we don't use calculators, so you can't be examined for something like this. Yeah, so we're going to still have a look at more questions. Yeah, so but meaning here the angle it is 4 over 3. Yeah, and then we won't be able to do much with this one. We can just take it like it is 4 over 3. Yeah, so meaning you remember r cos theta plus I sin theta, and then you always have to plot, like you know where the quadrants are. You know how to read from the positive x-axis. So this question it was just wrong to be asked here. Yeah, because we don't have a calculator to divide. So let us quickly go now to these two. So here the imaginary part, so the imaginary part, it simply means it's 0. Yeah, so if I to calculate r is negative 3 squared plus 0 squared. So this will be equal to 3. Is it? Yeah, so it will be negative 3. So simply negative 3 times negative 3, it is 9, and then square root of 9 is 3. So meaning r is 3. And then now what about the angle theta? So here immediately you see that one thing is missing. You just have to consider what you have. So like here we have x, but y is 0. So since y is 0, it means if we are to draw this on a Cartesian plane, it is just going to be straight in the x-axis, because we don't have anything in the y. Y is not positive, it's also not negative, it's not going up or down. Yeah, so since we just have x only, and it's not supposed to go like that, x is negative, it will go like this. So if we read this from the positive x-axis, this is 180. So meaning theta is 180. Yeah, so where you are not being clear, you can always send me a text on WhatsApp. So this is the angle. So we have r and also have the angle. So we can write this in polar form. It's simply r cos theta plus I sin theta. So this will be, what did we find? R was 5, and then cos 180. So you should be able to know that where there is 180, 180 is just the same as pi. Yeah, so plus I sine 180. So 180 is pi. So I think we're learning bit by bit. I've revised with you that 30 degrees is pi over 6. And then now 180 it is pi. So this is the polar form. Yeah, and then we've spent so much time here. Oh, am I just being too calm? I'm too slow. Yeah, and then the other one, so this is y and x we don't have. So meaning x is not going to the right, it's also not going to the left. So we just have a positive y like that. So meaning the angle which you get, it is 90 degrees for this one. Yeah, so the polar forms, that's all we can say. And then the resultant you can calculate. It is 4 square, it is x is 0 and y is 4. Yeah, and then the angle, it is just 90. So these are quite rare questions. So this is how you go about converting these. So you can practice on these. So you can practice on question 22. You can now do all these. Yeah, so you should try them out. Try and answer as much as you can. So we've discussed something like this, something like this. Yeah, so practice, and you can show me your answers, like you see how you are moving. So let us now quickly run to converting from rectangular. We're going to convert from rectangular going all the way to from polar to rectangular. Yeah, so this one is relatively easy. So like they want us to convert to rectangular form. So here we have trig ratios. When we have trig ratios, it simply means that this is a polar form. So how we convert, we simply say this is 8. Oh, and then before we even do anything, so we just have to know how to evaluate cos 210 sin 210. Yeah, so we did this in our trigonometry lessons, trigonometry lesson 3 somewhere there. So to do 210, so I'm not going to answer this. So cos 210, when we start going, this is 90, we reach 180, 210 will be somewhere here. So this is the whole lot of 210. So meaning the helping angle, the reference angle, it is this one in here between the x-axis and this one r. So this angle, it is simply 210 minus 180 plus 210. So this is 180. How do you find this angle? So we've reached here. Oh yeah, so we're going to say 210 minus 180. So 210 minus 180, what are you getting when you do your calculation? So it's going to be 30 degrees. Yeah, so meaning where there's 210, it is actually 30. Yeah, and then you just have to consider the sign. So this will now be 8. So cos 210 can be written as cos 30. And then in the third quadrant, so we said all students take chemistry. So in the third quadrant, cos is negative. so we put a negative there. Yeah, and then we have plus I sine I sine 30. And then what about sine? Sine is only positive in the second, so in here it is also negative. So sine will have a negative. Yeah, and then from here when we close, this is 230. So it is now a matter of simplifying. This is negative, because 230, you should be able to say that you simply count the things on top of 30. So on top of 30 we have 3 things. So cos 30, it is root 3 over 2 minus I. What is sine 30? It is 1 over 2. Yeah, and then we can multiply by the 8 outside. So 2 into 2 it's 1, 2 into 8 it's 4. So meaning here we're going to have negative 4 root 3. And then we have a minus. And then this is I. And then 2 into 8 it is 4. Yeah, I4. But we usually don't write I4. We'll just write 4I. So in case you're wondering what has happened, we've simply multiplied 8 here and also 8 there, and then we can cancel. So this is the polar form. So I've shown you, you can try and do this. So show me your work. Not really, I know you can do this. So this is how you go about it. Yeah, and then now what do we proceed to? Okay, and then now we'll proceed to multiplying and dividing two complex numbers. So like if you have one complex number, let's call it z1, and another complex number z2. So when you multiply z1 by z2, what you simply do, it will be the modulus of r, or the modulus of z. The modulus of z1 it's r1. Yeah, so let me just write this in full. So if z1 it is equal to x1 yeah, so we use more of trig ratios. So z1 it is cos theta 1 plus I sine theta 1. So obviously z2 it will just be the same but with 2. So here the point is, when you multiply z1 and z2, what you simply do is you also multiply their moduli. So r1 and r2 you multiply, and then in brackets you are going to say cos, and then now you add the angles, the angle for r1 plus the angle for r2, and then we have plus I sine, again the angle for r1 and the angle for r2. So this is what we would do when multiplying. And then when you are dividing, if we have z1 over z2, it's simply also r1 over r2. And then again also here cos, but we're going to have r1 minus r2. Here there was a plus, but we're now going to have a minus. So maybe an example would do better. So you can be asked a tiresome question like this: find the product and quotient. Although maybe they can just tell you to find the product only, or they can also tell you to find the quotient. So to find the product and quotient, you just remember that for the product, when you are multiplying, so this is dividing. When you are dividing, you simply say theta 1 minus theta 2. And then when you are multiplying, it's adding. So now, this is the first complex number and this is the first complex number. Here we are going to say we need to know R, we also need to know the angle theta. So R1, it is simply square root of -1 and root 3. So this will be square root of, here this is 1, and then when the square cancels with this, it's 3. So we're going to have 4, and R1 it's 2. Yeah, so this is our R1, and then what about R2? R2, it is our x, it's -3, and then the number with I, it's just a 1. Yeah, so here we're going to have, here will just remain with 3 plus 1. 3 plus 1, 4, the root is 2. So R2, it is 2. And then now, what about the angles? So the angles, key thing, always know that you have to know, you have to make sure that the angle is being read from the positive x-axis. So for theta 1, it's y over x. So y is √3 over x, which is -1. So our theta 1 is -√3. So -√3. And then what about our theta 2? Yeah, so but before we can even go there, we can finish it here. So this √3, you always have to know that it goes hand in hand with 60. Yeah, and then so this is 60. So but we're not going to just plug in 60 anyhow. So we should ensure that the angle is read from the positive x-axis. So this 60 y, or this is x. X is negative, it goes to the left. Y is positive, it goes up. So meaning 60 is there. So to read it from the positive x-axis, it will start from here. So this is a 120. We simply say 180 minus 60. So meaning theta 1, it is 120. Yeah. And then let's go to the other one. Let's go to B. So you can pause the video and then try to solve. What angle are you getting? So here y is 1. Y is 1. X is -√3. Yeah, so here 1 over √3, you just know that this is a 30 degrees. Yeah, so this is a special angle, 30 degrees, and then ensure that it is being read from the positive x-axis. Positive x-axis. So x is negative again. X is negative, y is positive. So meaning our 30 is here. So this means that when we read the angle from the positive x-axis, we're going to get a 150. So Q2 the second theta is 150. Yeah, so now from here now we know R1 and R2 we had found 1 and 2 and 2, and then here we now have 120 and 50. So we're going to say the product R1 R2 cos, you add the angles, and then also there you add. Yeah, so from here we are going to say R1 was 2, R2 was 2 cos theta 1 we found 120. So you remember you should always be able to know the angle in radian measure. So you should be able to convert 120 to radians. Yeah, so but questions will usually not specify, but usually it's best to leave in radians, like after you solve and then you convert, because mostly the marking key will be in radians. So 120 blah 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 180. So this is 4 cos. So what is 120 plus 180? We're getting a 300. So even here it will be a 300. So this is the we're not done. So we're having a cos and the sine, so we're still in polar form. So they said we should live in standard form. Means this means we live in trigonometric form. Yeah. So now we would have to evaluate cos 300 and also sine 300. So 300, it is simply it is here after 270. This is 300. So meaning the helping angle, it is there, which is 360 minus 300. So the helping angle is 60. So this means that we can write cos 300, we can write it as cos 60 plus I sine 60, sine 60, like that, because this is what we can work with. We know the special angle for 60. So and then be careful with the signs. In here cos is positive but sine is negative. Yeah, and then what is cos 60? When you count the number of items above 60, you know that it's just 1. So 1 over 2 minus I sine 60, it is root 3 over 2. Yeah, and then we can multiply both sides by 4. So when you multiply by 4, it means we're dividing. Yeah. So 4 divided by 2, it will just remain 2. Yeah, so this and that cancel, minus. Also here when we have a 4, 2 into 4 it will be 2. So meaning they cancel, we remain with a 2. So we have a 2 and then we have an I and we have a root 3 there. Yeah, so this is the standard form. You've seen that we don't have any trig ratio at this point. Yeah. wait, oh yeah, so this is when I'm realizing, so I think I might have actually made a mistake on this 180. Yeah, so it was supposed to be 150 ish. Yeah, so but you follow this same procedure, like you're just going as far as you can simplify. Yeah, so first let me correct it. So on this angle, which I'd put 180 for the second theta. Yeah, so let's just quickly do it here. So the second theta, remember it is always y, the imaginary part it is y, which is 1 over x, the real part is negative root 3. So you just see 1 over root 3, so the negative, it's like we can just ignore it. So 1 over negative root 3, you just have, you know that it's 30. Yeah, and then when we draw this, when we draw it, it's going to, x is negative, meaning we're going this side, y is positive. Yeah, so meaning our helping angle, which is here, it is 30. Yeah, so I made the mistake in determining this angle. So this is supposed to be 180 minus 30, and then you're going to end up with 150. Yeah, so here we're just supposed to do 150. So 120 plus 150, but you just go on to simplify. Yeah, so we just want to kind of revise so that you get these. And then what about when we talk about the quotient? They said we should also find the quotient. So R, we have R1 over R2, it's equal to so R1 over R2, and then we're going to have cos theta 1 minus theta 2. Yeah, we just go on with subtracting. Yeah, so theta 1 minus theta 2, hold on. Yeah, theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Yeah, so from here, remember R was 2, the other R was 2, and then cos the first theta, it is 120, and then the other one it's 150, plus I, the first theta 120, 150. So this will just remain 1, 2 over 2, 1, and then cos. So this one here to be cos negative 30, 20 minus 50, 30. Yeah, minus I sine 120 minus 150, 30. Yeah, and then we go on. So here you should be able to take note that when we have cos a negative angle, yeah, so cos it's something like even, and then even here we have a negative, so the negative for cos, it will go away. Yeah, so this is equal to, so we're supposed to be bringing the equal sign, so here we just have cos 30. And then for sine, the negative, it comes here. So I sine 30. So when we have a negative in front of the sign for cos, it disappears, so to say. But when we have a negative in front of sine, it comes in front of the sign of the in front of the angle, then it will come here. Yeah, and then from there we just simplify further. You should always know that cos 30, it is when we count the number of items above 30, should be root 3 over 2 minus sine 30, it's 1 over 2, and then we can put I. So that's how you go about this. Yeah, so the key thing is just to know that you need to find R. You need to find R, you need to find theta. When you are multiplying R1 and R2, means the angles are adding. If you are dividing, the angles are subtracting. Yeah, so now can we go to the Moivre's theorem? So for this one, how do we make it very quick? So I have now come to this. How do you write it? Yeah, demo something. So this guy used to be poor. He used to be poor, and one thing about him, he predicted his death. Yeah, so the Moivre, he was a mathematician and something. Yeah, but that is a story for another day. But I just know that he was broke, sadly. Yeah. So we're going to look at powers of n. Yeah, so don't predict your death like our lovely scientist here. So if we raise a complex number to a certain power, the Moivre, he was able to come up with a way in which you can do that easily. So if we have z power n, so remember z, it's equal to r cos theta plus I sine theta. So now when you raise a complex number to a certain power, then that power will also bring it to r, and then it can also become, or it would become the coefficient of the angle also here. So when you raise a complex number to a particular power, the power comes on r, it comes down here and there, and this is the Moivre's theorem. So we are now going straight to an example. Yeah, so I planned to make this as short as possible, but unfortunately I know, because I've decided to also combine it with complex numbers or with matrices, it's going to be a little bit long. So find the value of this and write the answer in rectangular form. So writing the answer in rectangular form, meaning we should get rid of cos and sine. So using the Moivre's theorem, so I've raised it to power 5. So this is our r. So this is r cos theta I sine theta. So actually the other name for the polar form, where we use 3 ratios, you can also write it as r CIS. Yeah, so actually this came in a test, in a certain test 1 for 2024. It was asked that what is the other form of writing the polar form. So this simply means r, c is cos, this is I, the imaginary part, and sine theta. Yeah, So some books, that this is how they usually write. So now remember, when we have a power on 5, it will come here on the modulus. So we're going to have 2 power 5, and then cos 5 will come down to be in front of 30, and it will also come down here 5. Okay, it's okay if we put brackets like that. Yeah, so 5 will come down to be there. So here 2 power 5 should be somewhere 32, and then this will be cos 5 times 3, 15, plus I sine 150 as well. So, and then they said we should leave it in rectangular form, so we should be able to simplify this part. Yeah, so if we have a sine, if we have 150, it simply means it is somewhere here, and then the helping angle, it is 150 minus, or 180 minus 150 rather. That is 30. So this means that where we have, so 32, where we have cos 150, we can write it as cos 30, and then I sine 30 as well. And then just take, you should just be careful with the angle. So sine is positive in the second quadrant, but for cos it's negative. Yeah, and then from here this will be 32. Cos 30, it is root 3 over 2, plus I sine 30, it is 1 over 2. And then from here we get to simplify further. 2 can cancel with that, meaning we have a 16, and then plus 2 also, when it cancels with that, 16, and 16 is having an I here. So this is how you can work out that problem. Yeah, so let's do another question on the Moivre's theorem. So what else can we do? Yeah, so these questions, there are a lot. We'll be able to answer all of them, but that is something for later. So we've talked about this. Question 22, express each of the following complex numbers in rectangular form. Rectangular form, this is very easy, like what I've discussed. When you just see rectangular, it means that you get rid of the cos. Yeah, so like here you have to evaluate what is cos pi over 2, simply meaning cos 90. So you can find cos 90. You count the number of items above 90, for sine 90, number of items below 90. And then for angles like this one, 7 pi over 4, you have to first convert it. Pi is equal to 180. What about 7 pi? When you find it, and then you'll be able to simplify. Yeah, so here they simply mean like we're simplifying these parts, but at the end you multiply with what's outside. Yeah, so on the Moivre's theorem, we're here. And then I don't know why I feel so uncomfortable. Yeah, so for questions like this, so that they say perform the indicated operations, you have this part and this part, they are multiplying. So you can see this is R1, this is R2. So when you are multiplying R1 and R2, this means that you are going to say 3 times 8, it's 24. And then cos, this cos, it will add with that cos. So meaning we are going to have cos 225 plus I sine, the sine here and the sine there, 225. Yeah, so I wanted to talk on this. So even here, you say 4 times 2, you write 8 outside. Since we are multiplying the 2, simply means you add 50 and 100. You also add 50 and 100. Yeah, and then for this one, we're dividing. So here you say what is 4 times. So are these even so clear? So I'm just guiding how to answer these, but if you still want to be sure, you can let me know. Yeah, so like 4 divided by 2, it is 2. And then since we're dividing, it simply means cos 190, cos, you say 190 minus 70, you write plus I, 190 minus 70, you also write. Yeah, so that's what you do also here. 12 divided by 3, 4. And then you subtract 200 minus 350. 200 minus 350. Yeah, so at least I've mentioned it there. So on the de Moivre's theorem, on the de Moivre's, we have said when there's a power, this power, it can become the coefficient. Yeah, so let's quickly answer something on the de Moivre's. And I don't know how to pronounce this word. So we have cos. So that one it will be, so here we don't have R. So but here you can see we have a 2. Yeah. So we'll say cos, this will be 12 and then pi over 9 plus I sine 12, the power comes down, pi over 9. So you can simplify this. 3 into, so this is cos 3 into 3, 3 into 9, 3, there is 4. So a 4 pi over 3 plus I sine, even here it's 4 pi over 3. So now to simplify, so what's the question? We're expressing the form where it should be raised to a particular power. Oh no, I wasn't here. So we're here to express into this form, the rectangular. So I was doing question 2. Yeah, so here the job would now be just you convert 4 pi. So I hope you remember how to convert. This was trigonometry lesson 1. So 4 pi over 3. I remember we say x is equal to 180. So we'll say x is equal to 180. So oh no, not x. So tired. So pi is equal to 180. So what angle in radians? Pi is equal to 180. So what about 4 pi? 4 pi over 3. It will be equal to what? We don't know. So here we're just converting 4 pi. So this will be x pi when we cross multiply, and then we're going to have 4 pi over 3 times 180. There 3 into 18, 6, and we have a 0. So 6 times 4, it's 240. So meaning here cos 4 pi over 3, it is just 240. So you can manage to find cos 240 and sin 240. You just remember, oh, okay, 240, it's there. It's in the third quadrant. So the helping angle 240 minus 180, that is the helping angle. And then you'll be able to calculate. Yeah, so that's what we can say there. Yeah, so but let's answer. I saw one which we're going to answer properly, this one. So let's answer question V together. Yeah, so we keep on pushing up to as far as we can go. So here's question V. So the question, let's see, what was it saying? So want to evaluate using the Moivre theorem. We see if we can take it to the standard form. So when it comes to math, you always start from where you know. By that I mean you start with the ideas. The ideas will be building up. So here we have a power. What do we know about a power? We know that this power, we're going to have 3. We have a 3 here. It will have the power. And then we're going to have cos. The same power will come down, and then we'll have 4. We have 3, the power has come down, and pi over 4 plus I sine the 3 has come down, pi over 4. And then the same will happen on the denominator. On the denominator we have a 3. We have a 3, but the power is 6. This will be cos. The power 6 comes down, we have pi over 4 plus I sine the power 6 has come down, pi over 24. We could have gotten a very confusing answer, maybe. Yeah, so here we'll say, let's see what we can simplify. So what is 3 power 3? We know it is 27. So 3 power 3 is 27. And then here we can't divide 3 into 4. Yeah, so you just say cos 3 times pi, it is 3 pi plus I sine 3 pi over 4. And then what is the power of 6? So this is you say 3 times 3 times 3 all the way up to 6 times, and then when you do the right thing you are going to get 729. So please, you can practice on this same silly thing. In case you come across it in a test, you will just be able to recall that here's 729. This is the importance of practicing. You won't take so much time, but if it's the first time you are doing 3 power 6, you have to multiply 3 by 3 by 3 by 3, and then that's when you end up to 729. So practice and be familiar with these. So here we're going to have cos 6 into 6, 6 into 24, it's 4. Okay, and then plus I sine. So here 6 into 6, 1, and then 6 into 24, it's 4. So from here we can now say we have 27 and 7, 29. So according to the rules of division, according to the Moivre's theorem, we simply say Q1, the thing on top, 3 pi over 4 minus the thing down, pi over 4, plus I 3 pi over 4 plus 5 pi over 4. Yeah, so how I'm feeling right now, I think we might not be able to do matrices. We might cut this video and then the matrices video follow later on. Yeah, but let's see where my energy takes me. So I have 27 over 729 cos 3 pi minus pi, it is 2 pi over 4. So whenever you have the same denominator, you just subtract the things on top, and then I sine 2 pi over 4, and then we can simplify here. 2 into 2 it is 1, 2 into 4 it is 2. So here simply means we have 1 over 2. So let us simplify. So this will be 1 over 2, 1 over 2. Yeah, and then from here this will be cos pi over 2. Pi over 2. So please, I'm revising with you. We said when you see 30, yeah, so this time let's even write them like pi. Where can we do this from? Yeah, so pi, you should always know that it's 180. When you see pi over 2, it's 90. When you see pi over 3, there's no pi over 3. Is there? Yeah, I think so. Now, so there's 90. The next one is pi over 4. It's 60. And then, even me, I'm confusing myself. Pi over 6. At least I know this one is 30. Yeah, so I have 30, 60. So maybe we don't have pi over 3, eh? Yeah, so these are just some things which you should know. Pi over 2 it's 90, pi over 6 is 30, and then I'm sure I am missing out something. Oh, okay. So pi over 3 it is there. Pi over 3 it's 60, and then pi over 4, that's 45. So these are some of the things which you should know. So here cos pi over 2, it's 90. So what is cos 90? So if you count the number of items above 90, we have 0 items above 90. So the whole lot of this should give us 0. Yeah. So cos 90. Oh, and by the way, so here you can also, you have to simplify. So like if you divide by 3, you have 9 over, what about when you divide 729 by 3? What are you going to get? You're going to get 243. So this is 0 plus sine 90, the number of items below 90. How many do we have? We have like 4. Yeah, 90, 60. So for those who are not familiar with what we talk about when we say the number of items below this, you can watch trigonometry lesson 1 and 2, where we get to perform these very easily. So 1, 2, 3, 4. So meaning sine 90, it is root 4 over 2. And then root 4 over 2 simply meaning 2 over 2. Yeah, square root of 4, 2. And then 2 over 2, it is just 1. So this means that sine 90, it is 1. Sine 90 is 1. And then we can't show 1, we'll just leave it as I. Yeah, so this question was very long. So I hate questions like this. Mistakes are very common when the question is this long. So we can also divide again. 9 divided by 9, it's 1. And then when we divide 243 by 9, we're going to get 27. So 27, so this times 0, it is just, okay, let's do this. Yeah, so this times 0, 0. And then 1 over 27i. So this is the final answer. Is there another thing that we can do? So also it's to talk about that. Okay. So this one, it's a very common test question where they tell you to find something like this. So they can give you power 16, whatever power they would dream to give you, and then they tell you to write in standard form x plus iy. So here we have a power, meaning we're going to raise r to the power, and then in front of course we're going to put a power I sign. Also here there will be that power. So firstly we need r. What is r? R, it is the square root of 1 plus 1 square x y. So this is root 2. And then theta, it is tan inverse, or tan inverse looks scary. So I remember I used to write it in this form. So tan inverse is equal to y, tan theta is y over x, 1 over 1. This is just 1. Remember, when you see a 1 dealing with tan, the angle we're talking about is 45. Yeah, so I don't know a way in which we can remember, but yeah, this, I think they are just few. 1 over root 3, it is 30. When you just see a 1, it is being single there, like 1 here, it is 45. And then root 3, it is it is what? It is 60. Yeah, so these, even in the document, I wrote them that thou shalt know. So now, since tan theta is equal to 1, it means that the angle we're dealing with is 60. And then these, they are both positives. So when we draw, x is going this way, y is going that way. So this is in the first quadrant. It is being read from the positive x-axis. So 60 degrees. 60, what are you doing here? So 45 degrees is just okay. Yeah, so but if it is somewhere here, there, or there, we have to read from the positive x-axis. Yeah, so our angle is 45. Our R, it is root 2. So what we have is, for this complex number, we have already written the form, this form. R is root 2 cos theta, I imagine sine theta. Yeah, so when we raise it to power 8, it simply means that root 2 is going to have a power 8, and then cos, so 8 will come here, theta, I sine theta, like that. And then you just go on to simplify as far as you can. And I hate this expression, how to simplify this. So 2, when you have a square root, it means that you are raising something to the power half. Yeah, when you have a 2, it means you are raising something to the power half. And then also have an 8 on top. So when you have a power of a power, according to the rules of indices from grade 10, when you have a power of a power, this will be half. Yeah, so sorry for saying, yeah, so but the rules of indices does, so this is 4. So sometimes I'm not comfortable when I explain things this fast. So please, you have this line. So in the documents, wherever you see my line, then I'm trying to communicate that. Inbox me when if you are not clear. Yeah, so this is 2 power 4. And then cos 8, and then our angle, it was 45. So this 45, at least we should simplify it. Yeah, so if you want, we can multiply by 8, but if you think about it, the answer is going to be very big. We're going to get just 360. Oh, okay. So I sine 45. So what is 2 power 4? We're going to get, is it 16? Yeah, this is 16. This is cos 8 times 45 is 360. 360. I sine 360. 360. So 16. What is cos 360? Cos 360. So you remember from trigonometry lesson 7, where we drew the basic graphs. So 1, 0, negative 1. The graph for sine, it goes like that. So sine, this is the point for 360. So sine 360, it is 0. And then what cos 360, it's 1. Yeah, so I don't know if you remember. So please, so I'll attach the video links for trigonometry from lesson 1. I'll actually attach the playlist. So you should watch lesson 7 if you have forgotten. So for cos, the graph looks like this. Cos 360, it's positive 1. So meaning here, this is a 1 plus 0. 16 times 1, 16 times 0. So that's our ugly answer. Yeah, So yeah, so this video is longer than I wanted it to be. Yeah, so but let's quickly go to roots. Roots of a complex number. So we're done with complex numbers. So what else can you answer from this? So these are questions from the tutorial sheet. Yeah, okay. Oh, so in the old tutorial sheet they used to like questions like this. Oh, the one were from answering. They give you power 8. They can give you 2 plus I power 12. Yeah, so we've answered that. Yeah, so you try to apply the rules which you know. Here the 8, it will come down, the 4 going there. Yeah, so I want to, so we've talked at least about one of these. Yeah, also the last part of complex numbers is to know the roots of a complex number. Yeah, so under the roots, so the roots of a complex number. Yeah, so remember, if we have what can we say here? If we have r cos theta plus I sine theta, if we have something like this, so this is the general expression of the complex in polar form. So now when we're not talking about the roots, we're simply saying, so like let's start from here. So like, you know, this is the square root. So what about this? What do you call it? You call it the cube root. This it is the 4th root. This is the 5th root. So these are the roots: square root, cube root, 4th root, 5th root, 6th root, 7th day, 7th root, just like that. So don't get offended, you people. Be smiling, Sam. God will be with you. Today is the Sabbath, but let us just push a little bit, just a small inch. Yeah, so what do I want to say? So if we have a root, so we're going to say the root of r is equal to cos. We're going to open here theta, the theta which we have there, but we're going to add the 360, or we're going to add the k and the 360 over, so here I have an n. So here this is n, meaning n, this is nth root. It can be 6th root, 4th root, so whatever root, yeah, we divide by 2. Yeah, so the other form of writing this, instead of writing 360, you can write it in radians as 2 pi. 360 degrees is 2 pi. So here we can write 2 pi if we want to write in degrees. Yeah, so this is the formula for the nth root. So this k, it starts from 0 going 1 up to the number of roots we have been taught. Yeah, so before I collapse while teaching here, let me just do an example, and then you have a rest. Find the indicated roots, square roots. Yeah, so there are more questions down. Cube roots of 27, cube roots of that. So how do you find the square roots of this? So it simply means that here we are going to have a power 2 r cos pi over pi plus k 360 over n. Where there's n, we'll be putting a 2. Yeah. So like that. So here we just need r. We need to know what r is. We need to know what theta is. Yeah. So the Argand diagram, it has been coming throughout. Like, you just have to know the modulus. So the modulus here, it is by now you should be able to tell that it's 2. Yeah. So this is 1 squared plus 3 squared. This is root 3. So they'll cancel. We're going to have root 4 and square root of 4, it's 2. And then what about our theta? Our theta, it is I'm dozing, sorry you people. Our theta is y over x. Y, it is 1. So maybe we just write it here. 1 plus I root 3. So the thing which is having an imaginary part, it is y. And then this is the real part, x. So y is root 3 over 1. So what is root 3 over 1 is root 3. And the angle that goes with root 3 is 60 degrees. Yeah, I mean 60 degrees, this is our angle. And then we have to make sure that it is from the positive x-axis. So y is, first x is positive, y is positive as well. Even the child will be positive. So this 60 is just okay, it's from the positive x-axis. So r is 2, theta is 60. Therefore, we can find the square roots. So we'll start with, so on the roots, meaning we're going to consider k. We're going to consider k is equal to 0, k is equal to 1, up to k is equal to 2. Here where there's cube, we could have gone up to 3. If they tell you fifth root, you'll be exchanging values of k up to number 5. So if k is equal to 0, what are we going to have? We're going to have zeroth root. Is there such? Yeah. So the zeroth root cos theta. So theta is 60. Yeah, 60 plus k. So remember 60 plus k. Now k, we're starting with from 0. So 0 times 360 over what do we put here? Yeah, over 2, because we're finding the cube roots. Yeah. Oh, and here there's no 0th root. We're just following with the square root. Yeah. So this will be square root of 2. So when there's the square root, we don't show the cut 2. So this will be let me conclude. So here, don't forget, we're also having I sine 60, and then k is 0. So whatever you have here, you also have on the other side. So this is cos 0 times 360, it is 0. So the whole lot of this is rubbish, or it's 0. So 60 divided by 2, 30. So plus I sine 30. Oof. So this is the first root. So this is the root when k is equal to 0. And then now you go on, now where there's k, here where there's k, you put 1. Yeah. So let us soldier on just 2 more minutes. So where there's k, we are at 0, now we put 1. So when we put 1, what are we going to have? When we put 1, we're going to have root 2 cos root 2 cos 60 plus 360, 420. I hope I'm not wrong. And then 420 divided by 2, 2 into there 2, 2 into there 1, should be 210. So when we simplify this part, it's 210. So plus I sine 210. So this is the second root. So these are all part of the answers. And then the third root, here when there's a 3, so you have to be showing your work. Here when there's a 3 times 360, you multiply, you add to 60, you divide by 2, and then you write your answer. So what is 360 plus 60? It's 420. And then what root are we on? So this, the first one was the 0 root, this one is now the first root. Okay, so now on the second root, here where this k, we put 2. So 2 times 360, we're going to get 720. So even here 2 times 360, 720, and then you add 720 by plus 60, it's 780. You also divide the same by 2, you end up with 390 plus I sine 390. Yeah, so this is the third root. So when they're talking about roots, when they say, when you're finding the cube root, you're going to have 4 answers. When you're finding the fourth root, you're going to have 5 answers, because we're starting from 0 and then 1, 2. Yeah. Okay, so we're going to end it here. Yeah. So I thought I would sum it up all the way up to matrices. Yeah, but can't we do it? Can't we do matrices like right now? Okay, so we'll just do matrices. Yeah, I was going to skip this, but okay, so the video will be like 2 hours. Yeah, okay, so matrices, we're not going to talk about the simultaneous equations. At least I just want to highlight on these. Yeah, so can we proceed? So matrices. So let's keep pushing. Okay, so talking about matrices, we get straight, no definitions. A matrix, so this is a plural, singular, it's matrix. So a matrix, it is whereby you have something that looks like this. So you should be familiar with the basic operations of matrices. So if you have this, that, so you should be able to add, you know, this will add with that, this will add with that, this one, it will add with this one. You only add corresponding items. Yeah, and then the concept of multiplying. So in a matrix we have what are called rows. These are rows, and these are columns. So we multiply row by column. So all those, the rows by column, multiplication also, can't we just skip it? Yeah, we're going to skip it. So like we multiply row by column, we would say 2 times 4, you see, plus 4 times 3. This is how we multiply matrices. So this part I have done it, and then let's come down here again, row by the same column, 5 times 4 plus this 3, 3 times 3 down here. And then coming to this part now means that you'll be multiplying by these other things. Again, row by column, 2 times 5. So actually you don't even have to be showing, like 2 times 5, you can just write 10. 2 times 5, 10, plus 4 times 4, 16. Down here means you come to this one, 5 times 5, 25. 3 times 4, 12. And then you add. Yeah, so introduction is done. Yeah, so but please, we can always move together when you are not so clear. So now we can talk about finding the determinant of a matrix. Let's say we have 2, 4, 5, 7. When we're talking about the determinant for a 2 by 2 matrix, this is common. You learned it in high school, where we say we say the product of the major diagonal minus the product of the minor diagonal. So in this case, this is 2, 2. You say 2 times 2 minus 5 times 4. So this would be 4 minus 20. So like if this was matrix A, we can say that the determinant of matrix A is negative 16. Oof. So that's how we do, that's how we find the determinant of a 4 by 4 matrix. Yeah, so you can never be asked to find something like this, because they say it is simple as that. So now where do we proceed? So with what I've talked about already, you can solve this. Yeah, so I'll take it slow this time. I don't want to be unfair. If this is 2, this is 3, this is 5, this is 6. If you want to find the determinant, you say 2 times 6, 12, minus 5 times 3, 15. Yeah, so these modular bars, they mean the determinant. So here it simply means we'll multiply this by that. So we'll say 2x minus 1, it will multiply 4x plus 2 minus we can start with here x plus 1 will multiply 2x plus what? Plus 1. Yeah, and then you go on to simplify 2x times 2x times 4x, you get 8. You get 8x squared. 2x times 2, 4x. Negative 1 times 4x, negative 4x. Negative 1 times 2, negative 2. Yeah. And then also here, x times 2x, it is 2x squared. So the thing about math is that it's easy. Now questions won't come easy because they'll just complicate things, because look, here we just had like a 1, here we had the 3, here we had the 5, here we had the 4. But now they have just put my x, just for confusion's sake. Yeah, and then you simplify. There's a square, there's a square. So all these have in a minus. So 8x squared minus 2x squared, it is 6x squared. 4 and 4, these they'll cancel. It's 0. And then negative 2 minus 1, it's negative 1. And then here we have x and x. These they make up 3x. And then since we have a negative outside, negative 3x, so this is a quadratic. You can try and finish it up. So we have our introduction to matrices. So what can we talk about next? Let's go to determinants now, which are more than 3. Okay, so now we're going to talk about this concept which is called the minor. So this is minor, meaning that this matrix it is under the age of 16. Yeah, so this is a minor. This is the minor of a matrix. It means that a matrix is under the age of 16. Yeah. Oh, and don't take that serious. So find the minors of the following. So now how you find the minors? Firstly, in a 3 by 3 matrix, you have to know that the cofactor of the first, this it's positive, here it's negative. So the first item here, positive, negative. So meaning under positive we're going to have a negative. So they alternate. Under positive we have a negative. So meaning after negative we have a plus. After plus, minus. After minus, plus, minus, plus. Yeah. So it's easy. You just start with a plus. Plus, minus, plus. Minus, plus, minus. Here plus, minus, plus. Yeah. So when you see this number, what does it mean? It means when you're not clear, you let him know. Yeah. So now to find the minor of 2, 3. So remember we said a matrix, it is made up of rows and columns. Yeah. So the first number here, it means a row. So minor of 2, 3 means the minor of the second row and the third column. Yeah, so 1, 2, second row. 1, 2, 3, third row. So now how do we find this? So well, let us write the madongo 7 and the person who was making this, they just had to 1, 2, 3, 4, 5, 6, 7, 8, 9. Very lazy. They couldn't put negatives to make it more interesting. So when we want to find 2m, m23 rather, then what we do is this we're going to cancel, like we're going to eliminate the second column, the second row and the third column. Yeah, second row, third column. So when we eliminate this, so when we eliminate this row and this column, what can you see? You can see that we're going to remain only with 2. This looks dumbo. 2, 7, 8. Yeah, so this means you eliminate second row and third column. Yeah, so when we eliminate those two, then we are going to remain with a 2 by 2 matrix. Yeah, and then what else? So from here we're going to say we're remaining with we'll remain with 1, 2, 7, 8, and we can now find the determinant of this. Yeah, you remember it is row by column. Yeah, so what is our major diagonal? It's 8 times 1, 8, minus 7 times 2, 14. So what is 8 minus 14? It's negative 6. Negative 6 there, as we can see. And then this is the part where now we'll come back to this. I'm sure you might have been wondering what's the purpose of this. So there's a way of finding the cofactors. Is it cofactors? Okay, all those things. Yeah, but so you just go with what is working better for you. Yeah, so I'm teaching through this method. If it won't be very much okay for you, you can use what you learn from the lecture slides, from your lecturers, and from all other sources. Yeah, so M23 we found negative 6. That's our negative 6 there. Yeah, okay, so now we are dealing with, so this is the minor. Okay, so let's not talk about the cofactors yet. So this is the minor. Yeah, so the minor, it is negative 6. We have found the minor. So we're going to talk about the cofactors on the next one, where we'll get to utilize this box. Yeah, so this is how you find the minor. So now let's go to question B. Yeah, so the best way of doing this, so you should be doing this especially when you are watching, when you are going through these math lessons. Like want to do M31, you can pause the video, try solving. You just solve on your own, and then you now skip the video 10 seconds until you see the final answer. When you see that my answer is similar to yours, then you have learned already. So you go to the next. Again, on the next one, instead of watching everything, you just pause, you solve, and then you see, okay, so my minor is this one. Maybe you found 6, and then you now press forward on the video so that you see what has been gotten. And then if it's not like my answer, and then you can try playing through the video. You see where you might have made the mistake, or I can even make a mistake myself. I usually make a lot of them. Yeah, so I want to defend myself. So let's find the minor real quick. The minor for 3-1. So I have 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. So now To find the minor, the first number means row number 1, 2, 3. We cancel this, and then this one means the first column number 1. We cancel this. You can see we are remaining with only 2, 3, 5, 6. So we can find the minor. The minor is just a term which is for the determinant, but this determinant is young. She or he is a minor. So this is 2 times 6, 12. 5 times 3, 15. Our minor is 3, negative 3. Yeah, so we're done with that one, and then we go to the third one, M11. Do you know what it means when we have M112? So now the minor for this, we cancel the first row and the first column. We remain with 5, 6, 8, 9. So if we find the minor for this, we're going to have 9 times 5, 45, minus 8 times 6, wait, I count, 45, 46, 47, 45. Yeah, I found my answer. I hope I haven't lied. This is negative 3. Yeah, so this is the minor. Yeah, so the minor, we have understood it. It has even become boring. Yeah, so apologies for this long video. Find the cofactors. So we have the same 3 by 3 matrix, but want to find the cofactors. So the cofactors, they are just minors, but with a dedicated sign. So there is that way of determining where we say we write negative 1 I plus j times the cofactor. Yeah, so there's this formula. Yeah, so it helps us to know this, to know the sign. So the cofactor simply means like we determine the exact sign which they want. So like if we want to find the cofactor of 2, 3, we first need the minor of 2, 3. We first need the minor of 2, 3. So the minor of 2, 3, 1, 2. We cancel 2. 1, 2. 1, 2, 3. Now we cancel this. So what are we remaining with? We're remaining with 1, 2, 7, 8. We can find the minor for this. Didn't we find already? 1, 2. 1, 2, 3. It looks different. 8 minus 14. We're going to end up with what is 8 minus 14, negative 6. Okay, so we have a negative 6. So here I hope this works. Yeah, because I'm trying to dodge the way they were finding the negative. So here you can see the intersecting point. It's here where this and that they are intersecting. It's here on 6. So what is the sign of 6 here? So you always know that here it's plus, minus, plus. So when we come down, minus. You can see here, this is what 6 is. Plus, minus, plus, here to be minus. So this means that this negative 6, we're going to write a negative outside for its position. It's on the position for negatives. So we have a negative and then negative 6. So this means that the cofactor, it is positive 6. So we said when you see this, it means what? I hope it's the one. So now let's go to the next cofactor, C31. So as usual, we first find the minor. 3, 1, 2, 3, 1. So I've remained with 2, 3, 5, 6. What is the minor for this? Right? This is 6 times 2, 12, minus 3 times 5, 15. This is negative 3. So now, what is the position of this? They're intersecting here. So we are starting with plus, minus, plus. So here we have a plus, meaning outside we are going to have a plus, negative 3. So this is negative 3. Are we getting the idea? Let's push. Don't give up yet. So we go to the last one. Almost done. The cofactor for C3. We first need the minor for 1 1 rather 1 1. So 1 1 we remain with 5 6 8 9 kwa. So we're going to have 9 times 5 45, and then due to experience I now know that 8 times 6 is 48. Most of you don't know. You don't know what 9 times 7 is. So this is negative 3. And then what is the position here? The first position is for positives. So plus negative 3, which is just negative 3. So this is the cofactor. Yeah. So this is how we evaluate cofactors. I hope you found it quite useful. So can you try one more? Okay, now it will take more time. So now we're now going to the part where the reason why we're learning about minors and cofactors, it's because they are used to evaluate the determinants. Yeah. So let's just get rid of this. So now we're going to find the determinant of the 3 by 3 matrix. That's something I want you to be able to have. I don't want to say an idea because I know you have ideas. Okay, so now let's do. You know how to find the determinant of a 2 by 2 matrix. Major diagonal, minor diagonal. But what if you have a 3 by 3 matrix? This is where the minor and the cofactor comes in. Okay, so now let's do the determinant of matrix A. Let us work out the determinant of this. This one looks a little bit easier. So the one for B, it will be your homework. Yeah. So after solving this, you should be able to get the answer is 0. That's the determinant. Yeah. So you can try practicing. Yeah. So let's see what we can get from this. So how you find the determinant of a 3 by 3 matrix is you pick one column to follow. You pick one column, or you can pick one row. You find you do like you're finding the cofactors of that row. You just do this alone, then you find. Yeah, so I think we'll even test. Should we test? We'll see. So what I mean is like, let us follow this column. we're going to follow it. We're going to find like the cofactors of each of these, and we would have found our determinant. So what does it mean? So we're going to find the cofactor for 1, 4, 0. So it is in this case. So let us start with 1. This one here, 1 is a positive. So we're finding the determinant of this whole matrix. So 1 is a positive. And then if we're considering 1, so we're going to hide the row and column in which we find 1. Yeah, so you can see like this is some kind of an intersection. Yeah, so here where 1 is found, we have cancelled, meaning we're remaining with negative 2, 3, positive 5, negative 1. Yeah, so this is the part for 1. And then let us go to the next number. So the next one, we have a 4 here. You can see a 4. So let us hide the things for 4. Yeah, so always I hope I won't lose you. This is plus, 4 is a minus, so we say minus 4. So if we hide 4, what are we having? We're having a 2, a 3, a 5, a negative 1. Yeah, so this is the part for 4. And then the last item, it is 0. So plus, minus, plus, so meaning plus 0. So if we hide 0, we're going to end up with I think, let me be hiding them in a different color. So if we hide 0, I remain with a 2, 3, 2, 3, negative 2, negative 3. Yeah, so what do we get? We're going to have 1, negative 2 times negative 1, it's positive 2, minus 5 times 2, 15, minus 4. 2 times negative 1. So here you can even hear that I'm very slow. So mistakes are very common here, especially when they give you something like what I wrote in my exam. They gave us such a big matrix. After solving, I just prayed that I hope I haven't made the mistake. Yeah, so 2 times negative 1, negative 2, minus 5 times 3, 15. Why are these having the same? Wait, I hope I haven't made the mistake. Oh, this one is. So 5 times 2 times negative 1 is negative 2, and then 5 times 2, 15. Oh, here we don't have a negative. Plus 0, 2 times 3, 6, negative 2. And then so here you can see that I'm even like, maybe I'm even being so slow. Yeah, so but you can just like pause, and then, so wait, let me finish here. 6, and then minus 2 times 3, it's negative 6. So always be careful when there's a negative, you have to show it so that you know that they'll cancel. So at this point you can just pause the video, and then you simplify everything, and then you just skip to check what I've done. So this is 1, negative 13, minus 4, negative 17, plus 0, 6 plus 6, it's 12. Yeah, so we're finding the determinant of matrix A, and the process is very long. I don't know if we'll prove that we shouldn't. So 1 times negative 13, negative 13, and then 4 times 17, it will be negative and negative positive, 68. This is a 0. So negative 13 plus 68, I've gotten a 55. So this is the determinant. This is very common, like in an exam, maybe multiple choice. Yeah, so these lectures, they are very crooked, they are very wicked. So our answer is 55, but they can give you even a 5 by 5 matrix, like just to make sure that you waste your time. And there's also another formula for finding the determinant where they do, how do they do it? They count, you go up, you start from down going up. Yeah, there's that formula, you can use it as well. It's all about finding what's easily adaptable to you. Yeah, so we used this to find the determinant. So I was trying to say, if we want, we can use this column, like we'll say positive 3, and then we hide on 3, and then we say minus here negative 3, we'll hide this part, meaning we have 1, 2, 0, 5. Yeah, so I hope you get the point. I hope so. So if you get the point, please can you do this? Can you do this one? Find the determinant. Yeah, and another exercise, anyone wants to try, 987654321. So you can comment on the video what you get, what's the determinant. Yeah, so this is how you find the determinants. Yeah, so even this one you can manage. Should I help you a little bit? Like you can choose like that, you just choose any. Yeah, I just wish we had so much time, but we can prove many different ways. We can prove, like we use this one, it will still give us 55. We prove this, it will still give us 55. Yeah, even here when you use this, it will give you 0, 0, 0. Yeah, so this is just the answer when you calculate. So that's on the those. So now something nice. So this is exam material. This is what they will ask you. Find the value of k. Ouch. I shouldn't have brought this. So finding the value of k. So you know what to do. Like we can use this. We can use any, but just making sure that we choose what won't give us a lot of problems. So what can we do? I'm finding third to select 100 to choose something very easy. I hope either way to go easy. So how about we work with this? Okay, let's work with the top row. Yeah, so don't be afraid though. So we're going to select this row. Okay, I'll just do it like we did it in the first one, so that at least we're consistent. Maybe even when you're answering, maybe you can just go in the first column. Yeah, so what if we use the first column? Now the only challenge is that we can have a quadratic, which I'm trying to avoid, k and k, so we'll just go this way. So what does it mean? It means this is plus, minus, plus. So we start with k. So we put plus outside. So here it is like we just have one thing. Now there are two terms, so positive k plus 3. Positive k plus 3, when we cancel this, we're going to remain with negative 2, 1, negative 3, 3. And then we go to the next one. We go to 1. 1 should have a negative. So when we cancel 1, we cancel the row for 1, or the column for 1, and the row. We'll remain with 3, 1, negative k, 3. And then we go to the last one, 2. We're going to say it's negative 2. So, and it has to be plus, but the same 2 is having a negative in front of it. So when we hide the column for negative 2, we're going to remain with this 3, negative 2, negative k, negative 3. So this will be k plus 3. We multiply negative 6 minus, this is negative 3 times 1. Yeah, so please here you have to be very careful. Yeah, so this negative, it's automatic minus. So when we multiply minus, negative 3 times 1 is negative 3. Yeah, so usually the mistake which we usually make is we write negative 6 and then we write minus 3. Like because this times this is minus, forgetting that you have to put that negative. So we're saying negative 2 times 3, negative 6. And then minus negative 3 times 1, it's negative 3. Minus 1 here, 3 times 3, 9, minus k. And then this is now minus 1, 3 times 3, negative 9, plus 2k. So that this is equal to 0. Okay. So what will be the value of k? So we're going to have k plus 3. So this is negative and negative, it's positive. So for you, you write like positive. Yeah, positive. So negative 6 plus 3 is negative 3 minus 1. This can be simplified further. This also can be simplified further. Now we open the brackets. Negative 3 times k, negative 3k. Negative 3 times 3, negative 9. Look at the mistakes. Negative 9 minus 9 plus k. And then here it's plus 9 minus 2k is equal to 0. Some questions, I hate them. So negative 3k plus k minus 2k. We're just collecting like terms, so they are done. So what things don't have k? Minus 9 and another minus 9 plus 9 is equal to 0. Okay, so this is negative 3k plus k minus 2k. This is negative 4k. This is negative 9. Okay, so negative 9. So it's at that point in math where you just like, okay, I just hope all went well. Over 4 over 4. So this answer, I don't trust it very much. 9 over 4. Yeah, so this is how you can conclude. Yeah, so it's just a matter of, and you can never know which one is the best to use. I remember I entered into panic mode into my test one, like after using such, the answer wasn't looking promising. I had to use something else. Yeah, so you can you can do that if you have time in your test. Yeah, so here I've just showed you the process, the procedure. Yeah, but this shouldn't, I don't trust this. Yeah, so but again, I'm feeling too lazy to go through. I'm dozing. Yeah, so let's see what else can we push for. So this is on the matrices. Yeah, oh, and then there's that question where they'll ask you the involving one. So now let us go through this, which is, you can be told that matrix A is, they'll give you anything, like they can be any numbers as long as the matrix is very large. 1 2 3 3 4 6 2 5 7 6 4 1 8 9 0 2 1 5. Yeah, so whatever the lecturer will just dream of bringing. Yeah, so especially the question, there's a question like this in the lecture slide. Yeah, so you should practice on it. It is having 4 by 4. It's a 4 by 4 matrix. Yeah, so this, it takes up quite some time. No wonder to carry a number of marks. So let's get to it. So you just choose one row or one column which you work with. Yeah, so like let's say we choose the first column, then we're going to have if we choose the first column, meaning we're going to find like the cofactors for each of these. So we start with 1. So 1, and then don't forget, like this is plus minus. Yeah, that's how they alternate. So taking the first one, 1 is positive. So if we cancel the row and column for 1, we're going to end up with 2 5 6 1 8 9. Oh, so these are cancelled. Yeah, I didn't cancel nicely. Yeah, so these are cancelled. So I have a 2 1 5. Yeah, oh, and then but for you don't have to show like, no, these are cancelled. Yeah, so and then we say the next one is 6. We're going to say minus 6, and then if we cancel for 6, how are we going to do this? Yeah, so if we cancel the part for 6, okay, so this is our question. Let me just save it. So let us start afresh. We said starting with 1, we will ignore the items that make up column 1 for 1 here. So 1 is a positive, plus minus. So depending on the crazy lecture I'm preparing, they can give you like 5. Yeah, but I doubt that's too much. So this is 1, positive 1, and then we're remaining with 2, 5, 6, 1, 8, 9, 2, 1, 5. And then the next item, it is this 6. It's going to have a negative. So when we cancel and cancel, we're going to remain with those who have 2, 3, 4, 1, 8, 9, 2, 1, 5. And then we come to 4. 4 will have a negative, a positive rather, plus minus plus. So I cancel. But 0 is cancelled. So here what we remain with is 2, 3. We have 2, 3, 4, 2, 5, 6, 2, 1, 5. And the last one now is the part for 0 here. So here 0, it goes. So 0 is a minus. So what do we have? 2, 3, 4, 2, 5, 6, 1, 8, 9. And then so now at this point again, so now from here we now have a 3 by 3. So like this is the common thing whereby they'll ask you to find the determinant of a 3 by 3 matrix. Yeah, so remember you only choose one thing and then you say plus 2, and then you have a 4 by 4 after cancelling, and then you say minus the next thing. Yeah, so in short, so this part we're just learning it. I'm just taking you through, in case you meet it, at least you'd have some idea. Yeah, so you always have to put up your best ideas. So like here now we'll say this one, okay, yeah, so these we're going to multiply them at the end, as in we want to find the determinant of this, determinant of this, determinant of this, determinant of this, and then we're going to multiply by their cofactors. So these they are cofactors. So what is the determinant of this? Meaning we're going to choose just one column or one row. So like let's say we choose this column, meaning the determinant for this will start with a 2. This question, are we? So we start with a 2. I've decided to use this column. So meaning let's get rid of where there's a 2 and there. So meaning we're going to have so when we get rid of that and that, we'll have 8, 9, 1, 5. So this is just the part for this one. And then so this is on this. And then now the next one is, we have chosen this, we now consider 1. So minus 1, the next thing is minus. So here minus 1, and then the brackets, and then the last one it's positive 2, and it will have its own brackets. So this what we have done, what we'll do here, it is just for this, meaning also here we'll do that, and that. Yeah. So we'll do now here, for 1, it means this and that will cancel, meaning we'll remain with a 5, 6, 1, 5. Yeah, and then we come to 2, the last one here. Yeah, so when we cancelled on 1, we remained with a 5, 6, and 1, 5. And then now, what if we cancel the last one where there's 2? It means we're going to remain with 5, 6, 8, 9. So 5, 6, 8, 9. So what is the determinant for this? So this is 8 times 5, 40. 8 times 5, 40, minus 1 times 7, 7, minus 1. 5 times 5, 25, minus 6, plus 2. 4 times 5, 20, minus 48. And then you simplify these further, where you say 40 minus 1, it is at 39, and then 39 times 2, you get your answer to be 78, minus 25 times 25 minus 6, it is 19, and then 19 times negative 1, we have a minus 19, and then 20 minus 48, we're going to have a negative, which is negative 28, and then negative 28 times 7 outside, you get negative 196. So this is the, and then we sum them. So you first, like, you deal with this negative 19 minus 196, it will be negative 215, and then 78 minus negative 215, we'll have a negative 137. We'll have a negative 137. Yeah, so meaning the determinant for this part, it's 137. So meaning you do the same for this part. You say you consider one column or one row, you make 3 of these, and then you go on. Also here you do the same, also here you do the same. Yes, I think you can see to even make this video to be way too long. Yeah, so but that's what you do. So like here we have 137. It means we have one answer for here. So we have one. Now we have, let's say, 137. It's a negative. So even here you find the determinant, you get maybe 90. Here you find the determinant, you get 120. Here you find the determinant, maybe you get negative 115. So after finding these determinants, that's when you multiply them by the numbers here from what we chose, like we had the 1. Here at the end you multiply by negative 6. Here you multiply by a 4. Here you multiply by negative 0. So you just get a 0. Yeah, so that's how you go about it. Yeah, so I think we'll take it up to this point. Yeah, so this was just a quick intro to matrices. Yeah, so in the other lessons we're going to finish up with the adjoint, the inverse, and the simultaneous equations. Yeah, so so wishing you all the best in your upcoming test. Yeah, so if you manage to reach up to this point, then yeah, that was great. Yeah, so keep on doing what you can. All will be well. Yeah, so and you try to revise through everything, everything you've done. So don't forget where you are coming from. Revise as much as you can. So do you remember we were finding the quadrants all the way from lesson 1? You can have different questions asked in different ways. Yeah, so changing from degrees to radians, these are common multiple choice questions. And then these, do you remember? Yeah, so but I know you've tried as much as you can. So from trigonometry lesson 11, where we answered this, and then from the document on lesson 8, we're looking at that. Yeah, and then this was answered in the document for lesson 11. Yeah, and then the graphs, and then this was in lesson 6, those the practice questions. Yeah, and then also this. So we've tried as much as we can. We've answered this in the documents, and then yeah, and we have seen what we can do from these. The roots, well, we have an idea. Oh, so when to find the root, it is the nth root, square root of the nth root, and then cos pi plus 360, or we first write a k, or you can say 360k over n, meaning while there's k, you'll be putting the power or the numbers from 0 all the way up to the root you want to find. Yeah, so we continue with our lessons later in the days ahead. Yeah, so wishing you all the best and good luck.